Hello everyone, this is a presentation of Data Science and Big Data Final Project. Our project focuses on analyzing online fraud job postings. Throughout this project, we have three key findings. First, we found out that fake job ads aggregate in some specific features. For example, most fake jobs are admin or engineering jobs. We also explored common requirements for job hunters, teamwork, work experience, and customer service as the most popular words occurred in job description and requirements. In the end, we developed a fake job detector using grading boost and tree model, which achieved 97% F1 score and could be deployed soon. Next, we will demonstrate the entire project with details. Our project is the fraud job posting detection, and we're group 1. I'm Jessica.
And I'm Arkesh.
Today, our demonstration divided into 5 parts: the overview, exploratory data analysis, data preprocessing, modeling, and conclusion. There are two motivations that lead us to choose this project. Currently, the entire world is affected by the COVID-19 pandemic. To control the spread, a lot of businesses have shut down, and therefore many people lose their jobs. After this pandemic come to an end and the economy start to recover, the job searching market would be boom. And the second motivation comes from our personal experience as new graduate students. Both of us are looking for internship or full-time jobs recently. We found out that some fraud job postings are hard to detect. If you invest the time or energy into fake jobs, we might lose other opportunities. Therefore, we want to create a fake job detector to help all the job hunters to avoid those fake jobs. To put this problem into machine learning language, we form the problem statement. Here we want to build machine learning tests to classify the job posting as fake or not. To achieve that, we will let the classifier learning from the label dataset. During the learning process, the goal of the classifier is to minimizing precision and record, which are great performance metrics when evaluating imbalanced dataset. Aside from the ML task, we also have several questions we want to explore. For example, what are the most common requirements identified in job description? What kind of roles are most evident in fake job posting? Answers to these questions could help us gain some insights about those fake jobs. So let's have a look at our dataset. We get this dataset from Kaggle, which contains over 70,000 jobs with nearly 900 of them labeled as fake. So this dataset is heavily imbalanced. So that's why we choose precision to record as our performance matrix. In this dataset, we have 16 features. The type of features are diverse. We have categorical features, binary features, and raw text. We first explore the categorical features. In this part, we focused on exploring whether there are some features or values highly correlated with labels. Then we found out that specific values in location and job function columns have a higher proportion of fraud jobs. There are 78 and 74% of jobs in Sydney and Houston are fake. In terms of job function, 26.7% of fake jobs are administrative and engineering jobs. We also found out that company logos and the telecommuting options could be a good indicator for detecting fraud jobs. Next, we explore raw text features, which includes company profile, description, requirements, and the benefits. So we first conduct the basic text analysis to see the most common words in each column. Then we also applied LDA topic modeling on each column to see if there are any interesting topics revolving under each column. We found out that teamwork, work experience, customer service are the most common words in terms of job description and requirements. To dig deeper, technical skills and soft skills are the two groups of skills mentioned frequently. Next, my teammates will demonstrate the data preprocessing and the modeling part.
So our data pre-processing mainly consisted of 4 steps. We first dropped the features which had a lot of null values. In our case, all of our job postings didn't have the field called salary range, so we dropped that feature. Next, we had a lot of textual columns such as job and company description. We converted this into raw numbers using TF-IDF, which basically gives the frequency of each word as a ratio of the frequency of the word in the entire data set. We used one-hot encoding to convert these numbers into categorical columns. And then we finally used min-max transformation to scale our data and also to deal with the issue of missing features, data imputation using a median strategy. So there were four common methods that we use for all our models. We first started by splitting the dataset into train and test in a ratio of 75% to 25%. To avoid overfitting and maximize generalization of our model so that they perform well on test data, we use cross-validation. We used grid search CV to find the best hyperparameter combination for each of our model. And finally, our data set was highly imbalanced. We had about 18,000 real jobs and 1,000 fake ones. So instead of accuracy, we decided to use precision, recall, and ROC curves. Coming to our candidate models, we decided to use decision trees as our baseline models. Historically, they have been known to be good binary classifiers, but they don't really scale well. So our main two candidates were SVM and LGBM. SVM, before the advent of neural networks, were the most used binary classifiers in the industry. But as with decision trees, they don't really scale well and take a long time to learn. LGBM, which stands for Light Gradient Boosting Models, are a combination of decision trees and the boosting algorithm. They actually take a bunch of decision trees together, and their final prediction is obtained by aggregating the result from each of these decision trees. The advantage they have over decision trees is that each decision tree in the LGBM is shallow instead of the original decision tree, which can grow to a huge depth. Next. So the primary metric here in this slide we can see is AUC. AUC is nothing but given 100 fake job postings, how many times our model accurately predicts it as fake. We start with our decision tree, which gives us a AUC of about 0.864 or 86.4. This was our baseline model. We then move on to SVM. We can see that SVM gives out a really good AUC score, which is about 0.98. Although this is a really good score, SVM takes a long time to learn the data and also doesn't scale well. And as the COVID-19 pandemic ends, we know there'll be a huge boom of job postings, and therefore we need our model to scale well, which leaves us with gradient boosting trees. We can see the AUC of gradient boosting tree is about 98.9, and it's great for scaling. It's great for large scale computing, and this is the model we decide to productionize. So we see two business opportunities with our model. First will be to collaborate with job aggregators such as LinkedIn and Glassdoor. They can use our model to actually filter out each job posting before they're actually posted on the website. This will help save time on the company's end and also on the end of job seekers. Second is we create our own app which uses the model as the backend. We scrape data from LinkedIn and Glassdoor and give out predictions whether that posting is fake or not. This app will be primarily aimed towards grad students, but although if it does well, we can scale out to other portions of the world. Thank you. That's our presentation.